Okay, we have learned that any base raised to the 0 power is equal to 1. Guess what I'm still seeing out there? So watch. Guess what I'm still seeing out there? People will see some base raised to the 0 power, and they'll do, okay, a to the 0 power is equal to a. Is that correct? No, the whole thing becomes 1. It's not just the exponent becomes 1. The whole thing goes away and becomes a 1. So just don't forget that. And then we've also learned the product property of exponents. When you multiply the same base, then you're going to add the exponents. So notice we have this a to the n times a to the n. We are multiplying the same base, so we can combine this by adding our exponents, right? We've already learned this. Yeah, we're all good with it. Okay, so let's go through this one because it's tricky. It gets us practice in everything, and then we should be good to learn the new stuff. So we have here, so if you want to take notes on this, you can. I'm okay with you just watching this if you are comfortable with that. So we have negative 3 x to the 0 a times by negative x to the 4th a to the negative 1. Question, is negative 3 connected to x to the 0? No, it's negative 3 times x to the 0. Okay, so is this negative in the exponent up here with the 4? No, it's a negative in front. Is the negative connected to x? Somebody says yes, somebody says no. What do you think?
Oh, wait, no, there has to be a 1 in front of it.
Okay, awesome. Way to remember that. So really, technically, there's a 1 in front of there. Just like negative 3 isn't connected to x to the 0, negative 1 is not connected to x to the 4th. Okay, so just remember that. That was a good reminder. That one's a tricky one. That's why I'm doing it. Okay. Going through this, we can reorder this as negative 3 times by negative 1. I'm putting my numbers by each other. So negative 3 and negative 1 just took care of that. I'm reordering it. Times x to the 0 times any other x's. Any other x's? No. Okay. And then we have a times a to the negative 1. Okay, let's go through this and simplify it piece by piece. Negative 1 times, negative 3 times negative 1. When you multiply the same base, you add the exponents. Does that hold true for numbers? No. So negative 3 times negative 1, you just multiply those, you get positive 3. All right, looking at x to 0, nothing that we can combine with x. We still have x to the 0 for a second. I'm going to write it as x to the 0. And then we have a times a to the negative 1. So when you're multiplying the same base, you're going to add your exponents. Okay, so it's negative 1 plus nothing, right?
It's going to be 0. There's not going to be an a because it's negative 1 plus negative, positive 1 plus negative 1 is 0.
Okay, good. So she just said that there was a 1. Where did you come up with positive 1?
Because there's always a 1 above the 8.
Okay, that's what I was looking for. There's always a 1 above the 8. So now when you multiply the same base, you're going to add the exponents. 1 plus negative 1 is 0. So we have a to the 0. Okay, awesome. So then, what happened to my x to the 4th? I forgot to write that. Did anyone notice that?
Yeah.
Okay. Okay, well, that's salvageable. So we had x to the 4th in here that I forgot to write for some reason. I was wondering, I'm like, this does not seem like I did the same problem. Okay. Does everybody see that I forgot to write an x to the 4th? Are we all okay?
Yes.
So then we have 4 plus 0, which is actually 4. Okay, so continuing to simplify this. So we have 3x to the 4th, and then what's a to the 0?
1.
It's all 1. So times 1, not a to the 1. Did you all hear that? Are you paying attention?
Yes.
Not a to the 1, it just becomes 1. Do we add 3 and 1?
No.
Well, there were no addition signs in here. Nope. So this is just 3 times 1, which is 3. So we have 3x to the 4th. This would be our final answer. Any questions on that? Now that was review. Okay, so now we're going to learn the new thing. But while you start writing this down, we're going to learn the new thing. While you start writing this down, this rule right here, I want to say a few things. Today's lesson can be either one of two things. It can either be really easy, and that's how it was for my first hour, or it can be really hard, and that's how it was for my third hour. Now here was the difference, and I just know that this is the difference. My first hour paid attention to the little details. The little things I was saying, they were paying really close attention to. The other hour just kind of was like, oh yeah, I'm watching, yeah, I get what you're doing. They started doing it on their own. The whole class was getting them wrong. And they weren't it's because they didn't pay attention to the little details. So I'm going to urge you today, Pay attention to the little details and what I say to you, okay? Because they matter. Okay, so the quotient power property. Okay, it says when you divide the same base, then you will subtract the exponents. So once again, if you're dividing the same base, then you're going to subtract the exponents. So I have a to the n divided by a to the m. Does everybody see how I'm dividing the same base? So then I subtract my exponents. Now here's a very important thing. Very important. You always have to subtract the top from the bottom. Once again, it's very important that you always subtract the top from the bottom. Does that make sense? Now this doesn't work for numbers. If you have a number being divided by a number, this rule doesn't work. We're talking if you're dealing with the same base and you're dividing the same base, then you'll subtract the exponents. Always the top minus the bottom. Okay, any questions on this? Yeah.
Well, if they're the same numbers on top and bottom.
Then you could either just simplify it by numbers, or you could still do properties of exponents. So if you had, there's two ways. Let's say we had 3 over 3. Those are the same base, right? So we could do it the easy way and say 3 divided by 3 becomes 1, or we could do it by exponents and do, we know this is 3 to the first power and this is 3 to the first power. So then 1 minus 1 would be what?
0.
So 3 to the 0 is 1. You see how we got the same answer 2 different ways? Yeah. Okay. Great question. I love that question. Okay. Let's do our first example. Starting out very basic here, guys. Starting out very basic. X to the 5th divided by x to the 3rd. When you divide the same base, you will subtract the exponents. Always subtracting the top from the bottom. So looking at this, we'll simplify it. It's going to be x to the 5 minus 3. The top minus the bottom, which is x squared. X to the 2nd power x squared. Very good. Questions on how I did that? Starting out very basic. Now, I'm going to show you quickly why that works really quick, but I'm not going to have you take notes on it necessarily. Just watch because it's kind of cool. It's kind of interesting. So the reason this works is because really x to the 5th, and I'm going to go off to the side over here. X to the 5th is x times x times x times x times x 5 times. So we have an x to the 5th on top. And on bottom we have an x to the 3rd. So we have an x times an x times an x. So having nothing to do with this, I'm just going to ask you a different question. What is 2 divided by 2? 1. What's 20 divided by 20? 1. So what's x divided by x? 1. No. Anything divided by itself is 1, right? No matter what. X divides by x and becomes 1. X divides by x and becomes, how many x's are we left with? 2 on top, so x squared. That's why it works. Now the reason you're like that seemed easier than that, right? How many of you are feeling like that? That was easier than that. That might be true for something very simple like this, but what if I said to you on a test, x to the 100 over x to the 53? Would you want to draw out 100 x's?
Yes, absolutely.
No, you wouldn't. So you wouldn't have time. Okay, so you'll use properties of exponents, yeah.
So instead of writing your work, like you said, equals x 5 minus 3, can I just subtract 5 minus 3 from the bottom?
Yeah, you can. I'm just going to always show all my work so that no one gets confused on what I did. Yeah, and when we get to the harder ones and we start dealing with negatives and all this weird stuff, showing your work will really help you not make errors. So you'll see, but if there's something like as simple as that, I don't mind you thinking about it. You know what I mean? So yeah, let's do the next one. 4x to the 3rd divided by 2x. 4x to the 3rd divided by 2x. So we have 4 divided by 2. Can we use properties of exponents? No, we're just going to simplify this. What's 4 divided by 2? 2. Now, pay close attention to the details here. I'm going to show my work so that later on when we get to the harder stuff, we're not going to make any errors. So really, essentially what we're doing is we're saying, if we want to do it, talk about it the long way, 4 divided by 2, you're right, it's 2. But we have to be careful. So I just want to urge you to try to show your work a little bit. Because essentially what we're doing is really dividing 4 by 2 and 2 by 2. So really we're just seeing that they both divide by 2. Now you'll understand later why I'm showing my work. 2 divided by 2 becomes 1. 4 divided by 2 becomes 2. So essentially, you're right. 2 divided by 1 is just 2. But we know it for sure goes on top, right?
Yeah.
Okay. So I'm going to keep my 1 just for a second, just so that later on we don't get confused. You'll understand why I'm doing it in just a second. All right, so now we have x to the third divided by x. Now, what's the exponent down here? 1. And it's always, since we're dividing the same base, we'll subtract our exponents. So we have x to the 3 minus 1. So I'm going to draw my line again so I can write things in the correct place. And then later on, I can get rid of the 1. So we have 2 over 1. And then x to the 3 minus 1. 2. And anything, guys, I don't want you to write your answer like this. Anything divided by 1 is just itself. So our final answer in this one would be 2x squared. Some of you are like, well, then why did you keep the 1? Why did you show all that work? Are you just trying to be annoying? But no, I'm trying to help you because later on we're going to get to some more difficult ones, and there's a lot of errors that usually happen. But if you're practicing things like this, you won't make as many errors. And then yes, when we get more advanced, like by the end of the year, my students would like look at this and they just do it. But at first, it took them a long time to get it. So let's do another one. Now we're getting juicy. We're getting juicy. Here we go. We can do it though. So we have on top 5x to the negative 3 y squared divided by 3x to the negative 4th y to the 0. Now if you're out there saying this is easy already, so I'm going to zone out, I think that's maybe what happened to my third hour class. They were lost. They didn't pay attention to the little details. They didn't ask questions, and they were all getting them wrong. So please just pay attention and please ask questions. Okay, let's go through and simplify this one piece by piece. So let's look at our numbers first. You guys about ready? Are you guys about there? Sorry, I didn't mean to go ahead. You guys have that written down because I don't want to get ahead. Okay. Now looking at my numbers here, 5 divided by 3. Do I subtract numbers? No. This is 5 divided by 3. Does 5 and 3 have anything that simplifies? No. Okay, so 5's got to stay on top, 3's on bottom. 5/3. That doesn't simplify. Okay. Moving on. We have an x to the negative 3 on top and an x to the negative 4 on bottom. Now, do properties of exponents change if we have a negative, or are they the same? It's the same. Just like with multiplication, we were multiplying and had negative exponents, and we still add them, right? Same rule applies. If you're dividing the same base, you're going to subtract the exponents, even if it's a negative. But you always have to subtract the top from the bottom. Okay, so we're looking at x's. So we have x to the negative 3, the top. Now, I urge you to show your work on something like this because you will make errors if you don't. Negative 3, and then I'm going to type in, I'm going to write a minus, and then it's the bottom. What is the bottom? Negative 4. Does everybody see that I did the top minus the bottom? Yes. Now, this is where the most errors come in, and I promise most of you will make most of your errors right here. So be careful, it's the top minus the bottom. So a lot of people forget that it's a negative 4 on bottom. Questions? Okay, let's move on to y's. And then we'll simplify x further in a second. So I'm moving on to y's. So we always do the top minus the bottom. So 2 minus 0, right? Okay, 2 minus 0. And now we'll simplify this down further. So I have 5 over 3. Those things don't change. And then we have x to the, well, let's see, negative 3 minus negative 4. What happens when you minus a negative? Good. Change it to a positive. What's negative 3 plus 4? 1. And then we have y to the 2 minus 0, which is 2. So our final answer, guys, anything to the first power. Listen to the little details. Anything to the first power is itself. So I want us to push ourselves to go further. So this is going to be 5/3 x to the first, which is x, y squared. Any questions? No? We're all okay? Feeling okay? Yeah.
Are you doing all?
Yeah, we're going to. And I'm going to sing you a little song just because it will help you for the rest of your life remember properties of exponents. It's only the beginning of the song still because we're only learning one property a day. And usually I teach multiple properties a day, but we're taking it slow. Okay, the song goes, when you multiply, you add. When you divide, then you subtract. Is that true? When you divide, you subtract your exponents.
Yeah.
When you multiply, you add?
Yeah.
True, but that song only works for not numbers, but properties of exponents. So that song only works if you have the same base. Okay, so before we do another example, Well, maybe we should do another before we move on. You want to do another before we move on? Yeah, we're going to do another real quick. I'm going to insert a blank slide. Okay, this is my next one. Here we go. Let's do a tricky one. Not really that tricky. So we have 2 over 4. X cubed, b squared. On top, let's go x, b. Yeah, let's do that. I don't want to get into negative exponents in our final answer yet, so that's what we're going to talk about next. Okay, let's simplify this one. Let's start with our numbers. 2 over 4. This is where most people make their errors. What's 2 over 4?
2 over 4, obviously.
What does it simplify by?
1 over 2.
1 half, 1 over 2. So you saw that both 2 and 4 divide by 2. 2 divides by 2 becomes 1. 4 divides by 2 becomes 2. Okay, sweet. So the 2 is on bottom. Leave it there. Don't float it to the top. And then on top, we have x cubed. What's on bottom? X to the first. And then we take the top minus the bottom. Let's skip steps in this one. So what are we going to do? 3 minus 1, which is 2. Good. X squared. The top minus the bottom. And then how about the bottom? B to the 2 minus 1, which is 1. Now our final answer, what's 1 times all that stuff?
It's just that stuff.
Just that stuff. Great. So on top we have x squared, and then we have a b to the first. What's b to the first?
Just b.
B, and that's all over 2. Okay.
I have a question.
Yeah.
So why did you times 1?
Why am I simplifying like this? Because I'll tell you why. That's such a good question. So some people are like, why are you being annoying and simplifying like this? Because people see 4 divided by 2, and they'll say that's 2.
Yeah.
But it's not, right? But it's not. So that's why I'm showing it like this, because then it helps them not make those errors. So a lot of us can see this, but really a lot can't. So, okay. So that's why I'm just showing how it works. Okay. Okay, so now we need to talk about negative exponents. Notice, in my final answer, did I end up with negative exponents? What about back here? Did I end up with negative exponents? No. All right, how about here, negative exponents? No. Okay, so that's because we've just so happened to have all problems where you never run across negative exponents in your final answer. But now we're going to, and that's not okay. We'll have to fix it. So, fun fact for you. Fun fact for you. You might get a negative exponent in your final answer, but that's not considered in the most simplified form. Just like we don't like being around negative people, right? Negative people make us sad, and we don't like to be around negative people. Math doesn't like negative exponents, so we want to make them positive. And there's a little trick that you're going to use to make them positive. Yeah. Awesome. You just flip it. Very good. So we might get an answer with a negative exponent. And this is how you fix a negative exponent. So everybody look up here. This is where I start writing. So you can flip a negative exponent. Yes, you can take a negative exponent and make it positive if you grab the base and you flip it over a fraction. So for example, if we have base A raised to the negative n power, we can make it a positive exponent by grabbing the whole base, flipping it to the bottom, and it becomes a positive exponent. So does everybody see how I grabbed it? It was up here, flipped it to the bottom, and now it's positive. Yeah, it'll just be over 1. Yes, unless you have something that stays on top. Because we'll get to an example like that. Okay. So the same goes, now this is where the common error comes in, guys. People will flip it, and then they'll still write the negative. That defeats the whole purpose of why we flipped it over a fraction. So make sure not to do that, okay? Okay, so looking at something like this, let's say in our final answer we had a negative in the denominator of a fraction. Just like over here, you'll grab it and flip it over a fraction, and that makes it positive. Is everybody okay with that? It will come with practice. So let's fix this one. Let's say we simplified something and our final answer was x to the negative 2. We do not like negative exponents. We're more advanced than that now.
1 over x.
Perfect. We grab it and we flip it over a fraction, so we have 1 over x squared. Thank you. Very good. Very good. Okay, now what about something like this? I'll tell you what. 8 out of 10 students will miss this on a test.
I bet I got this.
Okay, what is it?
2.
Uh-huh.
And 2 by itself, and it goes 1 over x. Power 2.
Okay, good. That's true. Okay, so for those of you that didn't catch that, what's my exponent on 2?
1.
Positive 1. Is that a negative exponent?
No.
No, so you need to leave it alone. So this is not a negative exponent. You need to leave it alone. But x to the negative 2 is a negative exponent. You need to grab it and flip it over a fraction. So 2 to the first power stays on top. And on bottom, we have an x to the positive 2. So 2 to the first power, guys, what is 2 to the first power?
2.
So we have 2 over x squared. So really what we're trying to get at is the 2 is not connected to x to the negative 2. It was on top, it needs to stay there.
So is that your final answer?
Yeah, that would be my final answer. Now what I want you to understand, these are equal. They're different forms though. This would be considered the most simplified form. This would not. They are equal, just like apples and applesauce, equal,
Apple.
both apples, but different forms.
We should
Okay,
totally play apples to apples.
we should one day. Okay, look at this example. This one's tricky. Negative 2, x to the negative 2, y cubed. So let's say we did something, we simplified it using properties of exponent, and we got this as our final answer. And stop here. No. Now, is there a difference between a negative number and a negative exponent?
Absolutely.
Yes, negative numbers are okay. Is that a negative exponent?
No.
No, that's a negative number. Leave it alone. It's okay to stay wherever it goes. How about x to the negative 2? Do we need to fix that?
Yeah.
And then how about y cubed?
That's fine.
Do we need to fix y cubed?
Yeah,
No, we don't.
No, just kidding.
Can we combine x to the negative 2 and y cubed?
No.
No, they're not the same base. So I'm just saying if this was our final answer, we'd have to simplify it further. Okay, so this has got to stay. So this has got to stay on top. Okay, I shouldn't have circled everything, but it's okay. Negative 2, it wasn't a negative exponent, so it stays on top. How about y cubed? Also stayed on top because it wasn't a negative exponent, but we did take this one, we grabbed it and flipped it over a fraction to make it positive. So that would be x squared. Any questions? Okay. How about this one then? 1 over x to the negative 3. Good, x to the third. You just saw you had a negative exponent, you flipped it over a fraction, and now it's a positive exponent. Okay. Let's put it all together. Well, we're going to do one more actually. This one's not, we can't simplify this any further. I'm saying, if you got this as a final answer, could we be finished?
Yeah, no.
No.
Before 1, 3 on top, 3x2 on the bottom.
Okay, so that's a good question. And the answer is no actually to that, because is the 3 a negative exponent? No, so it's got to stay where it is. And the 4, not a negative exponent, it's got to stay where it is. So once again, the 3's got to stay, it's not a negative exponent, the 4's got to stay, it doesn't have a negative exponent. This, however, does. So we're going to grab it and flip it over a fraction so it comes down here. It's now x to the positive 2. Does everybody follow me? Yes. I'm not finished though, but yes.
Can you just rearrange the y and the negative 3 and the x, just switch them?
That's exactly what we're doing.
Okay.
Yeah. So then how about the y to the negative 3? It was on bottom, but we can't write answers with negatives, so we're going to grab it and flip it over a fraction. So that's going to come up. So we have y to the third. That's my final answer. Does that make sense? Yes, sir. Questions?
Alex has a question.
Yes.
Not anymore, no.
Okay. Awesome. So that would have been our final answer. Please ask if you do, because I don't know if I'm not making sense or saying something clearly if you don't ask. Okay, let's put it all together. Here we go. Ready? A couple more examples, and I'm going to set you here to work for quite a while. So stay with me and pay attention to the little details. They make a huge difference. So we have on top 2x, y to the negative 3. I'll let you get that down. 2x, y to the negative 3 on top. On bottom, we have 4, x squared, y cubed. On bottom, we have 4, x squared, y cubed. Let's go through this piece by piece. It's really not so bad if we go through it piece by piece and simplify. Okay? All right, be careful. Be so careful. Let's focus on our numbers. 2 and 4. What's 2 divided by 4?
1/2.
It's 1/2. That divides by 2 and became a 1. That divides by 2 and becomes a 2. So I'm going to show my work. 1/2. There's a point to me showing my work. I promise. Okay, let's move on to our x's. I'm going to change color for x's. All right, so we have x to the what power? 1, and we're dividing the same base, so we'll subtract our exponents. The top minus the bottom. The bottom is 2. I don't like that I'm running into that one. Oh well. All right, and then we have our y's. So we have -3 minus, I'm going to write that in before I even look at this. Oh, 3 minus 3.
That's just going to be 0.
Okay, so let's keep simplifying because as you're going to see that there's a lot of common errors in this one. So I'm going to draw out my fraction so I keep things in the right spot. So we have x to the, what's 1 minus 2? -1. Be very careful when adding and subtracting things. Does everybody see how 1 minus 2 is -1? Okay, continuing. Now, careful. What's -3 minus 3?
Not 0.
-6. So we have y to the -6. So now, a lot of this, yeah, that is our final answer, but almost. Like, that is the same thing. It's the same thing as our final answer, but not in this most simplified form, right? What's confused? What are you confused about?
Back of
Yeah.
all of
Okay, so you get why we're doing this part, right?
them. Yeah.
So what's 1 minus 2?
That's 1.
1 minus 2 is -1. So that's why we put a -1.
Okay.
Okay, good question. And then -3 minus 3 is -6.
Yeah.
That's why we put -6.
Okay.
Okay, so we're not finished. We gotta keep going.
Okay.
Okay. Good question. Okay, so now we'll go through and fix negative exponents. Right here we have a negative exponent. We need to make it positive. We do that by flipping it over a fraction. So you guys, get in the habit of just rewriting it every time because people try to do it all in one and it gets so confusing. So I have 1 over 2. We just flipped x to -1. What's it going to be?
X.
To the +1. I'm going to show my list. And then we have y to the -6. It's also a negative exponent. I'm going to grab it and flip it over a fraction. So I'm going to get y to the 6. Questions to that? Our last and final answer. We have a 1 on top, right?
Yes.
We have a 2 on bottom, an x to the first, which is just,
X.
and then we have a y to the 6. Any questions? Okay. Do another one. Guys, let's do another one. I promise you, you're going to need them. Because once you start doing this on your own, it gets hard, especially because if you haven't seen a few examples. So we're almost there. Stay with me. 3u to the 0 v divided by 3u squared v cubed.
There's a lot of.
A lot of u's and v's.
I missed the numbers in that.
You what?
I missed the numbers in that.
What do you mean?
Well, letters there's numbers.
Oh,
Just numbers.
well, get used to it. We'll be seeing a lot of letters. All right, let's go through and focus on the numbers. 3 and 3. What's 3 divided by 3? 1. Okay, so that's a 1, that's a 1. Okay, good. All right, now, so I'm going to show my work. I have 1 over 1 for right now. And then I have u to the 0 divided by u squared. You always do the top minus the bottom.
Yes.
Okay, so we have u to the 0 minus 2, right?
Yes.
Questions?
Slow down.
Yeah, absolutely. So I'm going to circle that. We're doing the top minus the bottom, so that would be 0. I'm going to star it. And then minus, I put the minus before I came down here, and then it was -2. Okay, okay. Moving on to V's. What's my exponent right here? 1. So we have V to the, I always write that top one first. 1 minus, I'm going to write the minus before I come down here and look so I don't make any errors. I've been talking way too much today. -3. Okay, so simplifying this all the way down. So we have 1 over 1. U to the what? -2. 0 minus 2, guys. 0 minus 2 is -2. And then we have V to the what? 1 minus 3. 1 minus 3 is -2. Questions on that? Let's go through and fix our negative exponents. That has a negative exponent. I need to fix it. That has a negative exponent. I need to fix it. We fix it by flipping it over a fraction. So I'm going to bring those to the bottom. What is on top?
1.
1 over, and then we have a 1 times u to the, what?
2.
2. We grabbed it and flipped it under a fraction. It's now positive. And then v to the 2. Now, you guys, we're more advanced. We can't write our answers like this because you won't see it like that on a test. And what if it was multiple choice? So 1 over 1 times anything is just itself. So we'll have u squared v squared. I know this is easy for many of you, but it really is really hard for a lot of people. So I am going to do one more example. Just stay with me, and I'm going to let you work for a long time. So stay with me. Some of you are like, this is really easy, but I often find the people that are saying that will make the most errors. So just stay with me, because I'm doing each of these problems for a reason. I didn't just randomly write them up there. They all have a purpose, okay? And then I'll let you work. Here we go. 3x cubed y divided by 9x cubed y to the negative 3. I promise this one will look a little bit different. So just bear with me. Let's go through this. Okay, focusing on my numbers. Focusing on my numbers, let's simplify it. 3 over 9. Correctly, what does it become? 1 over 3. 3 divides by 3 becomes 1. 9 divides by 3 and becomes 3. So we have 1/3. All right, now we're doing properties of exponents. We always take the top exponent minus the bottom. So we're going to have x to the 3 minus, I'm going to change colors really quick. So we're going to have 3 minus 2 on x. Many. All right, and then with y's. My exponent on top is what? 1. We always take the top minus the bottom. Now careful with this one. So we have y to the 1 minus. Before I even look down, I write 1 minus, and then it's a negative 3.
Positive 4.
Is anybody lost? Okay. So simplifying this again, I'll come right here. So I have a 1 on top, a 3 on bottom. I'm trying not to cover that. So then we have x to the 3 minus 2.
1.
And then y to the 1 minus a negative 3. What happens with that? Positive. Good. Minus a negative becomes a positive. So we have y to the 4. So our final, do we need to fix any exponents? No. So our final answer will be 1 times all that stuff is all that stuff. And x to the first is just x. So we're going to have x, y to the 4th. Any questions on how this becomes this? And on bottom we have a 3. Okay, no questions. What?
Are you good at math?
No. I only have a degree in mathematics. Okay, ready, set, go. Do these problems. Do these problems.
Alex.
Yeah.